Anyway, so today I'm going to be talking about the Mariner 9.
You if you want to, you can Hi everyone, it's 1 o'clock here on IC Radio. I'm Amelia.
And I'm Helena. Welcome back to Mission Impossible, where we bring you the best science news, gossip and analysis.
And the best music. On our playlist today, James Taylor, The Animals and Earth Eater.
First, on this day in science history, NASA's Mariner 9 was launched into space in 1971, becoming the first spacecraft to orbit another planet, our red neighbour Mars.
Not only that, how can deep magma help us forecast volcanic eruptions? Dr. Catherine Booth from Imperial tells us.
Currently, we use seismicity on the ground and also understanding inflation around the shallow chamber and the upper crust, so that's at 5 to 8 kilometres depth, to forecast when eruptions happen. But it would be even better if we understood what happens in the deeper reservoir.
We will also dive into the unique cicada emergence in the US, where 2 broods of billions are coming up at the same time, an incredible event that only happens every couple hundred of years.
Then we'll quiz our contributors with some weird animal noises.
That's all between now and 2, here on Mission Impossible.
So, hi Helena, are you looking forward to the show today?
Hi Amelia, I really am. How about you?
Yeah, I'm looking forward to the quiz that we've prepared for our contributors. I think it's going to be quite funny.
I think it's going to be quite fun as well. I'm looking forward to it.
I think it could be quite difficult though. There's some strange noises in there. So.
Yeah, when I was listening to them, I was like, I never knew this animal sounded like that.
Yeah,
so
got something good coming up for everybody there. Yeah.
If you guys want to get in contact with us and make a recommendation, you can email us at science@19@gmail. That's 9 written as a number, so that's science@19@gmail.com. And also keep up with social media and even check out our TikTok. We've made some really cool videos on there.
And now, Airborne Ashes by Earth Eater and Alexander. that was Airborne Ashes by Eartheater and Alexander. It was a pretty kind of ethereal song, I thought. But now, on this day in science history, on May 30th, 1971, NASA's Mariner 9 was sent to Mars. It wasn't just the first spacecraft to orbit another planet, though. It also sent us images of its surface.
Our guest Shivani Sivakumar tells us about NASA's mission to our amusing red neighbour and what's to come. Welcome, Shivani.
Thanks, Helena. So, on this day 53 years ago, on May 30th, 1971, the first spacecraft reached the orbit of another planet. Mars has always intrigued space explorers. Being our outer space neighbor and having had a history of water existence on its surface, Mars is probably the most Earth-like planet in our solar system. And for this reason, it has not only been the subject of science fiction, but also the target for space exploration, because of the possibility of having human civilization on it. Here's a recording of a news program from the iconic day.
Mariner 9 is finally off on its 247 million mile flight to Mars, expecting to get there the 14th of November.
So the Soviet Union launched Mars 2 and 3 just right ahead of the American launch of Mariner 9. And there was an 11-day difference in those missions.
The American ship Mariner 9, also unmanned, will arrive in the Martian sky about the same time as the Russian ships.
Mars 2 and Mars 3, the Soviet missions, were even more ambitious because they carried landers as well. The Russians intended to beat NASA and the Americans, not just to orbit, but to the surface as well.
It was an exciting sort of breakneck competition, really neck and neck. The Mariner 9 probe was traveling much more quickly, so actually ended up arriving at Mars before the Soviet probes were able to arrive.
Mariner 9 approaches the most critical phase of its flight. A rocket engine on board will be fired to slow the craft down as it nears the planet.
You know, that rocket's been cold for 6 to 9 months, and now you got to stir it up, and it's got to work exactly right when you tell it to.
That's when something could go wrong. Fortunately, it didn't.
Mariner 9 is in orbit around Mars, the first time that man has put a space vehicle into orbit around another planet.
Mariner 9 is the first mission ever to orbit another body outside of Earth, other than the moon itself.
So while in orbit, Mariner 9 mapped 85% of the Martian surface, which was incredible for that time, and it gathered over 7,000 photos, which really advanced our understanding of just Mars. Here's another clip about the findings and what this meant at that time.
The Soviet Union had a successful landing of the Mars 3 mission. It actually captured images on the Martian surface, but because of the storms, it only lasted for a number of seconds.
And eventually, the atmosphere cleared very nicely, and Mariner 9 began doing what it set out to do, that detailed mapping, that detailed first-time reconnaissance up close of what this place was like.
We have a picture from Mars tonight taken from the Mariner 9 spacecraft, which is touring around the red planet. It shows a sort of huge Grand Canyon.
As we had never seen these kinds of things on another world in our solar system. We saw things that we recognize, volcanic structures, giant canyon systems, river valleys, you know, very Earth-like things.
Mars turned out to be a much more interesting object than we had ever anticipated.
I don't know what you guys think, but I think it's so cool to just see, kind of hear the excitement the first time we had photos of Mars.
Yeah, it must have been, you know, not to use this pun, but like out of this world. Like to see something that far away, but that looked almost similar to Earth. You know, they said it was Earth-like. It just must have been so exciting.
Yeah, definitely. I think so. So, Shivani, do you know if there's been kind of more progress in research on Mars so far?
Yeah, I think that kind of acted as a launching pad for decades of Mars exploration to come. And I think the sorts of rovers that are now there on Mars must have been so much more advanced than they could have possibly even dreamed about that at that time. And I think it's so interesting that the space race and just space exploration successes are just constantly built upon the shoulders of whatever came before. And I think just looking back, it's so cool for us to see what they thought of the first landing on Mars then. And I guess we don't even know what we'd be so excited about now, like which planet we land on next or what else we'd find about Mars that completely blows our mind. So I think just remembering the history of Mariner 9 today is such a good reminder of how our understanding of Mars and just space has been shaped over the years, and how that's been an inspiration for so many space explorers to continue doing all the cool things they're doing.
Yeah, definitely. And even inspiration for sci-fi, I think, is really cool. I mean, the film The Martian
I was
comes
just
to
going to say
mind.
that.
You know, that's meant to be one of, like, a really accurate depiction of actually what Mars is like. And you can imagine that it's similar to, they have storms there, they have, like, the landscapes are quite mountainous, a bit like here on Earth. Yeah, it's definitely inspired some really interesting sci-fi stuff there.
Yeah. I just think space exploration is such a cool space because you have so many different types of interests colliding. Like you have political interest, scientific interest, fiction, and just like for fantasy. It's just quite a cool space to think about, I think.
Yeah, definitely. I mean, they were talking about in that clip there about the Soviets had landed on Mars, but then obviously NASA are the ones who did the orbit, and at that time there was quite a lot of competition, so definitely that political aspect was very important there for how we managed to make such advances in our space exploration.
Yeah, definitely. And I think it's also really cool how kind of it's that kind of idea of like traveling to new worlds and kind of seeing these different places is really interesting, and also kind of seeing about how it's kind of inspired different people to become astronauts, so to kind of learn more about space is really cool.
Yeah. We also have one of our contributors for later. We've got Carissa here with us. Do you have any thoughts about this?
Hello, thank you. Kind of similarly echoing what you were saying, I can't imagine those big kind of groundbreaking discoveries happening now. I think that's one of the things that maybe is a bit more of a shame living in a more technological age, because you forget just how mind-blowing these things really are. And yeah, hopefully next year we'll have something even more exciting to say, some more leaps forward.
Yeah, definitely. Well, I think...
Yeah. I think that's definitely a reminder for us to kind of sit and think a bit more about, like, maybe kind of look up some images of space. I saw some really cool ones from one of the telescopes last year, so definitely a reminder for us to think more about space and science history. Thank you so much, Shivani. So we'll have to wait and see how long it takes us to reach Mars and the kind of exciting things we'll find when we get there.
But now, back to some music before our next guest. Here's Fire and Rain by James Taylor.
Just yesterday morning, they let me know you were gone. Suzanne, the plans they made put an end to you. I walked out this morning and I wrote down this song. I just can't remember who to send it to. I've seen fire and I've seen rain. I've seen sunny days that I thought would never end. I've seen lonely times when I could not find a friend. But I always thought that I'd see you again. Won't you look down upon me, Jesus? You gotta help me make a stand. You just got to see me through another day. My body's aching and my time is at hand. I won't make it any other way. Whoa, I've seen fire and I've seen rain. I've seen sunny days that I thought would never end. I've seen lonely times when I could not find a friend. But I always thought that I'd see you again. To an easy time, my back turned towards the sun. Lord knows when the cold wind blows, it'll turn your head around. Well, there's hours of time on the telephone line to talk about things to come. Sweet dreams and flying machines in pieces on the ground. Whoa, I've seen fire and I've seen rain. I've seen sunny days that I thought would never end. I've seen lonely times when I could not find a friend. But I always thought that I'd see you, baby, one more time again now. Thought I'd see you one more time again. There's just a few things coming my way this time around now. Thought I'd see you, thought I'd see you finally now.
That was Fire and Rain by James Taylor. From Mars landscape to Earth's surface, Federico Gieserich would break down Dr. Booth's research on how deep magma can help us better predict volcanic eruptions.
The purpose was to try and understand what the deeper magma reservoirs do. So we know that they exist within the crust, so 20 to 30 kilometres depth. And we also know that there are upper chambers where the magma is then erupted from. But we couldn't understand, there was not a lot of research over how magma from the deeper reservoirs then travel up to the upper crust and what controls their size, their frequency and their composition. So we wanted to use a numerical model to try and understand those processes and also how the source reservoir, so that deeper reservoir, then delivers that magma to the upper crust. And we generally found that it was the size of the reservoir that controlled the frequency of these eruptions, as well as the frequency of the sills being intruded to the reservoir. So the sills are what feed the reservoir and help it grow. And also the strength of the overlying crust, so how strong the overlying crust is. The source reservoir will control the size, frequency and composition of these eruptions because the upper chamber is so short-lived that the deeper reservoirs would control these evacuations.
So I see a little room for improving eruption forecasting there, is that right?
Yeah, so if we understand the deeper reservoir, we'll understand the volcano better as a whole. Currently, we use seismicity on the ground and also understanding inflation around the shallow chamber and the upper crust, so that's at 5 to 8 kilometres depth, to forecast when eruptions happen. But it would be even better if we understood what happens in the deeper reservoir, because that can give us a better understanding of the size of them, how frequent those eruptions are going to be, and also the composition of them. And this is mainly concentrating on the largest eruptions. So these volcanoes also might have smaller eruptions, and that could be mainly controlled by the upper chamber. But these big eruptions, the ones we've seen in Yellowstone, the ones from Santorini in the Bronze Age, these ones are the largest ones that have the most impact on the world. And we found that understanding deeper reservoir means we can understand those ones better.
Could you explain the processes of magma rising from deeper chambers to these shallower chambers and then from these to outside?
So generally, magma in the deeper crust is stored in a mush. This mush is basically partially molten rock. So it's mainly crystals from the magma, and then within these crystals there's little melt pockets. And because the melt is less dense than the crystals, so it's more buoyant, this melt rises upwards and gets trapped at the top of the reservoir, this deep reservoir in the crust. And that forms a layer of what we generally think of as magma, so that really molten rock. And that magma layer is buoyant, so there's a certain pressure it's exerting on the crust, so it wants to leave. And that buoyancy also causes Rayleigh-Taylor instabilities to grow. And these Rayleigh-Taylor instabilities are basically mushrooms. And you sometimes see it when you add milk to your coffee, you'll see little domes of mushrooms forming, and these are Rayleigh-Taylor instabilities forming. So we also see that in deeper reservoirs. But these Rayleigh-Taylor instabilities grow, and so does the buoyant magma layer. And when that pressure in that reservoir gets too much, that magma will then leave that deeper reservoir and will generally intrude into the shallow chamber. And we know that because we can see from evidence from the crystals that were within that magma that it's stored at depth for a long period of time, so over millions of years. It is then moved to the shallow chamber where it's only stored for tens of thousands of years. And then it then goes on to erupt, and that's the crystals that they then used to get the history.
You mentioned the buoyancy of the magma. Could you please explain what do you mean by that?
Yeah, so buoyancy, if you have a light object and you put it under something heavy, it will want to push against it. So like when you put a balloon underwater or a ball underwater, it will be lifting up trying to leave, and that's buoyancy causing that. So it becomes too buoyant. So for example, when you're holding a balloon underwater and you suddenly let go a little bit, it will just rise up, and that's what magma's doing within the rocks.
What about the methodology? How did you carry out your study?
So we used numerical modelling. So with numerical modelling, you find equations which describe how the liquid moves, how the solid moves, how the temperature changes, the heat changes within the reservoir. And we combine all of these equations along with an equation to explain how chemical reactions happen within the reservoir. We combine all of these equations into a massive program, and we solve these equations to then find out these properties. So we get the temperature profile of the reservoir, we get the composition profile of the reservoir, because obviously when the solid and melt is moving, they're exchanging chemical components. So we also get the composition of the reservoir. And from the composition, we can then calculate the density, so that's important for the buoyancy, and also the viscosity, which is important for the critical buoyancy for them when it will leave. And we also obviously look at the velocity differences, so the changes in the velocity of the crystals moving about and the liquid moving about. And we use that numerical model to then go on to looking at how that buoyant layer forms and when that evacuates.
Were there some limitations, and what's the future of your work?
So the limitations are that it's 1D, so it's one-dimensional. So we look at basically a transect through the crust. Obviously, it would be great to look at other dimensions. At the moment, it's quite difficult computationally, but we have developed a model for that. But we're developing it to have as much physics as it has currently in the one-dimensional model. We also then need to look at volatiles. So volatiles is either carbon dioxide or water. And that becomes very important in the upper crust because they'll turn into gas, and that will completely change the pressure, which is why we currently look at the deeper reservoir. And then when it goes to a shallow chamber, we just assume it's stored there for a short period of time prior to erupting. But to make our model better, we obviously want to look at what happens in the shallow chamber as well. And to do that, we need volatiles, which is also being added to the model.
So, Federico, can you tell us a little bit more about this research now that you're in the studio with us?
Yeah, sure. Hello. So the thing is that currently eruption forecastings are done by studying what's going on just beneath the surface, the Earth's surface. Yeah. And so we look at the seismicity on the ground, we look at shallow chambers, the upper crust, but actually an area of this research field which is really under studies, it's what's going on deeper, 20 to 30 kilometers deeper. And this can be really important because deeper chambers and reservoirs can actually give us a better overview of volcanoes as a whole, can give us more insights into the size, into the frequency of eruptions, into their compositions. And so, this can give us a better overview of what's going on in general, can help us understand better what's going on, and can help us monitoring and predicting volcanic eruptions. And so, of course, predicting volcanic eruptions is incredibly challenging, and this would be only one small piece of an enormous puzzle. But I guess that's how science works in general.
But also really important, something that's come to mind for me is I don't know how long ago it was now, but fairly recently, the eruption in Reykjavik. Maybe if we had more knowledge about the deeper reservoirs there, we might have been able to predict it sooner. I think it was quite an unexpected eruption.
Yes, yeah. And it's very important, yes, because this study in particular looks at those kind of eruptions. So it's not small eruptions, but it's about the big ones. It's about, for example, in Reykjavik and in the northern hemisphere of the Earth, there's really important volcanoes and the eruptions are really big, and that's what this study is about.
Yeah, impacts people a lot.
Yeah, definitely. And I think it's kind of really important for like health management and also like prevention of kind of like serious natural disasters like volcanoes. So could you tell us a bit more about how this deep magma works?
Yes, so the magma is stored deep as a mush, which means it's partly molten rock and partly crystals. And the thing is that since these have different densities, of course the molten rock, which is more buoyant and less dense, tends and wants to go upwards. And it will go upwards, and this will form a layer of buoyant and less dense material, molten rock, which is what we normally refer to as magma. Now the thing is that of course this magma wants to go even more upwards because it's buoyant and not and less dense than the rock. And so this is when the Rayleigh-Taylor instabilities, which were mentioned before in the interview, come into play. These Rayleigh-Taylor instabilities are instabilities, interferences between two fluids of different densities. And the way you can think it is, it's what happens when you put your milk into your coffee or tea. When you're pouring it, and there's those 2-3 seconds in which the two fluids are mixing, and there's that really messy cloud until then the equilibrium reaches and the two fluids merge together. So those are the Rayleigh-Taylor instabilities. And of course what happens there is that a lot of energy and pressure is being applied. And so when that pressure gets very, very high, that's when the magma will leave the deep reservoirs to reach the shallower chambers.
So understanding that pressure in the deep reservoir is what can help us predict the frequency of those eruptions.
Yes, exactly. That's an important point.
Okay.
That's really cool. That's really interesting. Thank you, Federica. I never kind of thought about how a coffee or tea could help you think about about volcano eruptions.
A good analogy there.
Yeah.
Definitely. So thank you.
Thank you.
So to all of our listeners, hope if you're just listening in now, this is Mission Impossible from 1 till 2 on IC Radio. So if you stay with us after a music break, our guest Carissa Johnson will explain to us the unique occurrence of billions of cicadas that will emerge in the US. But first, here's Distractions, Bugs in the Attic by Sia. So that was Distractions, Bugs in the Attic by Sia. But now we have Carissa in the studio. You might have, if you were listening earlier, might have heard her talking with us. But now she's going to talk to us about the cicadas in the US. Over to you, Carissa.
Yes, thank you. Thank you for having me. I'll give you a little warning now that this story makes my skin crawl a little bit.
Oh no.
So if you are someone who's sensitive to insects and creepy crawlies, that's your warning. Luckily though, we're only here talking in the studio and not actually in the eastern parts of the US, where they are experiencing a once-in-a-lifetime convergence, where 2 broods of cicadas with trillions of individuals are crawling through little holes in the ground and completely overrunning the towns and the land that they have there. So before we discuss that a little bit, let's have a look or a listen at what's happening in the States.
It's set to be the biggest invasion in hundreds of years. Not millions, not billions, but likely trillions of these pesky, incredibly loud cicadas. And right here in Georgia, the invasion has begun.
It is shocking to see this many.
And they're already coming out in South Carolina, where they're taking over Sarah Weinberg's backyard.
Did you think it was going to be this bad? No. I really wasn't prepared because I've never seen this before.
Yeah.
This is my first invasion.
Okay.
They moved in, and they have stayed.
Stayed mostly under her gazebo, clinging onto every corner and crevice.
They think this is a safe spot.
It's already getting so loud in Newberry County, people are calling the sheriff to complain.
We had a leap year, we had eclipse, now we've got cicadas everywhere.
Why so many this year? One set of cicadas comes out every 17 years, another every 13 years. This year, there's an emergence of both broods. That hasn't happened since 1803. They're coming out from Alabama to Missouri, and where they may overlap the most, Illinois.
They're talking, epic numbers, biblical kind of numbers of them in that area.
So something historic potentially is brewing in the Midwest.
It definitely is historic for sure.
Augusta, Georgia agriculture agent Campbell Vaughn says cicadas are harmless, but very loud.
The males are making the noise, and it's a little bitty buzz. I wonder if we can hear that.
So we have the sound level meter here. So let's pause and just see how loud they really are.
Getting about 60 decibels right here.
But at their peak, that could skyrocket to 100 decibels, about the same as a lawnmower.
Enjoy the noise. It's really a neat thing, so don't get too creeped out by them. She gets creeped out by them.
Not a pleasant feeling.
Yes, so you've heard a little bit there of people's experiencing living with the cicadas. I think it is quite difficult to overstate just how intense the whole phenomenon is. You hear a lot of people who talk about it reference the biblical plagues, which I think is quite fitting given the footage that I've seen. You do have every square inch of certain towns and certain areas covered with insects, and this is happening in 10 states across America. So that's as north as Iowa, as south as Mississippi, and as northeast as Virginia, which is quite terrifying but also quite cool. I think one of the most amazing things is how instantaneous it is. So it starts happening overnight. You can kind of go to sleep and you open your eyes and thousands of bugs have crawled out of the ground. I'm not sure how I would personally deal with that. I'm not sure if any of you guys in the studio are a bit better with insects and crawlies and such.
Oh no, I'm not good with bugs and creepy crawlies.
I don't think I'm too bad usually, but I think in this scenario, I think anyone would probably be quite creeped out by it. So.
Yeah. A cicada's harmless though.
Yeah, so they don't actually, they're not any kind of harm to humans whatsoever. I think the biggest harm is just maybe being a bit grossed out, and they do kind of keep to themselves. Also, just because this year is so special, the brood that emerges every 13 years and the one that emerges every 17 years are converging. And the last time that they came out at the same time in 1803, the Haitian Revolution hadn't even ended yet, so not many people do have to deal with conditions like this, quite luckily, but it's a very unique part of their life cycle. So one of the things that entomologists have kind of suggested is that the reason that they're on 13 and 17 year life cycles, being prime numbers, is so that predators don't learn the schedule that they come out, and it makes it difficult for predators to then sync up with when these emergences happen, because as you can imagine, at the moment they're having an absolute feast with all of those bugs out and about. So yeah, that is quite cool. They do have quite a complex life cycle, cicadas. So they spend over 99% of their time underground in the nymph stage, which they usually don't go further than a kind of cubic meter underground. They stay in quite a local area, and they aren't hibernating, which is what I kind of assumed that things do underground, but they spend the whole 13 or 17 years gorging themselves on tree sap, which they suck out of the xylem at trees, and then eventually they wait until the soil in May every spring, or the spring that they're going to emerge, hits 64 degrees Fahrenheit, and they magically know when enough years have passed, because they count how many times the tree cycle is growing new leaves. So every spring, once there's fluids going up the tree to help those new leaves sprout out, that's how the cicadas know, okay, it's spring, it's time to pop out. And they come out and they molt, and their mating ritual lasts 10 days, which is where you get all of that noise. The females deposit their eggs into the twigs in the trees, which then drop down and feed and burrow underground, and then continue the cycle all over again. Yeah.
So they stay as a nymph for 13 or 17 years in that brood's case.
Yes.
That's such a long time.
Yeah.
It's like a teenager forever.
Yeah, exactly.
Yeah, it is a really long time. And it is quite sad, actually, when you think about it, because they spend all of that time, 17 years underground, and then they come out for a few days, and they just mate and die pretty quickly. And the dead bodies of the parents that fall from the trees help fertilize the soil that then their babies grow up in, which is scary, cute. I'm not quite sure how to describe that.
I guess it's like they're helping the new generation, but it's also quite sad. They sound very smart though, like the kind of way that they know how to come out of the ground and to like come out and to see everyone like every 17 is quite precise.
Yeah. Well, thank you so much, Carissa. I hope everybody is not too scared of those sounds of the cicadas and are up for some more animal sounds with our quiz that we have prepared for the contributors, Carissa and Federico, and also for our listeners. But first, here is House of the Rising Sun by The Animals.
There is a house in New Orleans they call the Rising Sun, and it's been the ruin of many a poor boy. And God, I know I'm one.
That was House of the Rising Sun by The Animal. So, before we wrap things up for you today, we have a fun quiz for our contributors who have to guess what these different animal sounds are. So we've taken the first 3 questions of this quiz from the Natural History Museum as part of their Tune Into Your Streets campaign. And they're doing quite a large study on how noise pollution affects different insects. And they're encouraging you to take off your headphones and record insect sounds near local roads so they can train an algorithm to help identify them. And they hope that this can help us better understand how noise pollution affects insects and also give us a greater appreciation for the sounds that we hear on our day-to-day lives. So that's why we've kind of decided to do this today. So these are some of the questions we're going to ask our contributors. How are you guys feeling? You feeling confident?
Yeah, I feel like I've got this in the bag. Yeah.
No.
Federico, I'm disappointed to hear you say that as a fellow zoology undergrad.
Yeah, I'll do my best.
So maybe I'm disadvantaging you as these first 3 questions from the Natural History Museum are UK wildlife, so...
That's disappointing, Emilia, come on.
Some of it might be the same. So the first one, this is it a toad or is it a frog? What do we think?
Okay, that's really hard. I thought we'd choose between like a frog and a giraffe, not a frog and a toad. I'm gonna say frog.
Yeah, me too.
Yeah, you're both right. It's the croak of the common frog. So this, like, they obviously make a lot of these sounds a lot of the time, but some of the croaks that frogs do is for mating, as the males make special noises. So yeah, that's the first question. Over to Helena for the next.
Okay, so this sound, we want you to guess if it's a fox or an owl. That was
a bit haunting.
A very haunting sound. So, any guesses who's making this creepy sound?
I was unlucky enough to live somewhere where some foxes made a burrow right under our window. So I think it's bringing back some PTSD.
PTSD.
Yeah, I think honestly you can hear that sometimes in London. I don't know. Yeah.
Yeah, I'd say so too. So you're both correct. It is a fox. I've definitely heard that sound. I have the displeasure of hearing that, unfortunately. So this scream is actually made by female foxes during the breeding season. So the more you know.
That's really interesting because usually males make the breeding sounds.
Yeah,
right?
that's a good point actually.
Yeah, I thought so as well. But yeah, it's a noise I do hear a lot in London actually.
Yeah.
So the third one, this might sound a little bit like some of the clips earlier. Is this a cricket or a grasshopper? Thoughts?
My brain is braining.
Tuning into your inner invertebrate.
Come on, Julia Day, zoology to UCL, please. Come on.
I think maybe
I was gonna say cricket.
Okay, I'm gonna go grasshopper. So.
Okay, it was a cricket. Federico was right. You should have stuck with your first answer. So. Probably quite similar to what the cicadas earlier were doing. They rub their legs and their wings together to create that noise, and it's actually the male crickets, they call it singing, to attract the females. And every male cricket will have their own noise, and the females make kind of an assessment about which male they want to choose to breed with, and that's why they all have this different singing noise.
Wow, I wonder if it hurts rubbing your legs together like that. It makes quite a loud
Yeah, it's a very whistly sound.
Yeah, I think the cicadas had a special organ.
Wow.
They had like a thing in their abdomen that vibrated, which gave them that sound. So it's a bit more inbuilt.
Wow, that's really cool.
Okay, so the next one is a bit more difficult, but we keep things interesting. So this sound we're going to play, we want you to try and guess which animal makes this growling noise when it's stressed.
Do we just have to guess? Like,
Yeah.
I feel like there is a clue.
Yeah,
there,
exactly.
Partly. I don't know.
Is
if
it underwater?
It's underwater.
Yeah.
Because the sounds were quite regular. It sounded like maybe they were blowing air out or something quickly, or it almost sounded like something getting like electrocuted a little bit.
Yeah.
That's what I thought.
Is it a fish or something else?
You're on the right track, I would say.
Something fishy. Are they big or small?
Small.
Small, yeah.
Is it sea or freshwater? Oh, it's here. In the UK or in London?
Oh no, this is not. Sorry, we should have said this is not UK anymore.
Oh,
Just the
okay.
first three were UK.
Yeah.
So freshwater or sea?
Sea.
Is it?
I sound like I
Is it something really random like a shrimp?
No, it's a fish, right? We said it's a fish.
No, she said along the right lines.
Ah, okay.
Yeah, a type of aquatic animal.
Fish adjacent.
Fish adjacent.
But it's small.
That's a good way to say it.
So I guess it is quite random.
Yeah. Do you all have heard of it? It's not like some random animal you've never heard of.
Federico,
I am just trying to think, but you know.
How long do we put you through the pain of trying to guess?
Give us a hint.
I was actually just thinking that the noise, the name of the animal has another animal's name in it,
Oh,
and I
that's a
think
good
it sounds a
point.
bit like that animal.
Yeah, it does. I was just thinking that.
But that's quite hard if you're working backwards.
Yeah, if you're working backwards. Once you know it-
Seahorse.
Yay! Well done.
Actually, yeah.
Well done.
That's when it's stressed.
Yeah, when it's stressed. Exactly.
Poor guy.
Okay, so next question. This animal is making a chirping sound. What do we think it's from?
That's a bird. Obviously not.
Not a bird.
No.
Is it
Trick,
like
trick.
a little, like, squirrely, small mammal rodenty thing?
It's not small. I'll tell you that.
Interesting.
It's quite surprising, this one.
Yeah.
So it's big.
I was shocked by this one.
Yeah, me too.
Is it like a deer or something? Is it like a big...
It's a mammal.
It's a mammal.
A mammal, yeah.
Does it live in warm or cold environments?
Warm.
Warm.
How warm? Like savannah?
Yeah, like think you're on a safari.
Okay.
Like a monkey? Some kind of monkey? No.
No. It's it's a carnivore.
It's a carnivore.
Yeah.
Is it a hyena or something?
Yes.
No. Shall I tell you?
Already.
Oh well, we've not got. We want to do some other questions.
Yeah,
right?
yeah. Okay, go ahead.
So this one is actually a cheetah.
Oh.
Yeah. So both males and females use this sound to communicate a variety of emotions, but the mother can also use it to call her cubs. So it's a bit like a whistle. Get someone to come to you. Yeah.
That's really cool. I think it's really interesting how so many different animals have so many different sounds and like use it to communicate. Okay, so last question we have for you guys today. Which animal makes this noise?
That was clearly a Jurassic Park scene in which velociraptors were chased by an helicopter.
Wow, Federico, you got it. Well done.
It's not real.
Yeah, that sounds like it. Were all those sounds the same animal making it?
Yeah.
Oh wow. Okay, I thought they were like.
Yeah, that sounded. The first part sounded really different from the
second. Yeah.
Okay, so.
We'll have to press you for your guess, I think.
Okay.
Running out of time.
Aquatic animal.
Aquatic animal.
Yes.
I'm gonna go dolphin.
There you go.
Look
at you.
That was a good one. Yeah.
Nice one. Okay, so that's all we have time for today. Thank you, Carissa. Thank you, Federico, for joining us in Mission Impossible. Don't forget to tune in next Thursday at 1.
Okay, thank you so much, Federica. Thank you so much, Carissa, for coming on. Thank you so much, Shivani, as well. We've learned so many interesting stuff. Amelia, what's your favourite bit been about today?
I think they're all really good stories, actually. I think I found the volcano stuff pretty interesting, actually. Thanks, Federico, for that.
Thank you.
The cicadas too, but makes me feel a bit creepy. So what about you?
I don't know. I think the cicadas really interesting. I found it really interesting. They've got so much stuff going on, and they're really a lot smarter than you might think. So
and they live such a long time. That's
exactly.
Crazy.
Very cool.
But yeah, I also think the Mars thing is really important. Remembering history, remembering things that happen on this day is a really nice way to recognise really important breakthroughs in science as well.
You never know what could be happening today as well in science history.
Yeah, in 20 years' time, what might have happened on this day. That's a really good point, actually. Well, thank you very much for joining us, all our listeners. Once again, don't forget to tune in next Thursday at 1.
And feel free to follow us on social media. We are Science at 1. You can even check out our Twitter, our TikTok, our Instagram. Thank you so much.
And that's it. See you next week for more stories, gossip and music.